Hey folks, I kind of mentioned in a previous video that I was going to talk a little bit about how I convert vintage bikes to fuel injection. So I thought I'd talk a little bit about that today. First and foremost, usually one of the trickier parts of it is throttle bodies. So we had carburetors on a bike and now we're going to get rid of those and add throttle bodies. So in this particular case, since I was working with a 3-cylinder engine, I kind of scanned the market of what was 3-cylinder and modern, and obviously Triumph is one of the few that's out there. So these are off of a 2009 Triumph Daytona. So, which I believe it was a 670 something, 675 maybe, whatever. Anyways, so I think these are going to be about the right flow rate for the 750, since it's making a little less power and a little less high revving. So anyway, so that's what I started with. So the first thing I had to deal with is the fact that the outside diameter of the throttle body itself was obviously somewhat larger than the carburetors I was working with. In this case, these are 52 millimeter OD, whereas the carburetors I was working with were, I believe, 46. The next thing was the spacing between them. So these are, I believe, 83 millimeters and some change, 83¼ millimeters. And the bike, the cylinders on the bike I'm working on, this is for my XJ750 triple, they were 77 millimeters center to center. And so one of the first things I need to do is to make this wider. So I've already been through all this, and I put it back together so I can show you guys how this process works. This isn't the case for every set of throttle bodies. The ones I did for my Yamaha XJ750 was a 4-cylinder, and I used some different throttle bodies for it, and they were a little bit, the spacing method for that was a little bit different. But anyways, I kind of wanted to show you guys what goes into this, and how I go about this. So first thing we do is we're going to split this rack down. So we're going to pull the fuel rail off. That's the other thing with this is a lot of these stock bikes, it's really hard to find information for the fuel injectors. I ended up using the stock injectors on my last bike build, and I had a hell of a time. The tuner and I both had a hell of a time dealing with that, because there's not a lot of information available on the internet for what the flow rate and dead time and whatnot for these injectors. So a lot of it was kind of guesswork when it came to tuning. So I bypassed that with this particular setup, and I've got some injectors. We'll get to that in a minute. But so anyways, so this fuel rail is not going to be used, but I do need this fuel fitting. It'll come into play here in a little bit, but this fuel inlet fitting here with the barb on it that fed into this fuel rail. I'm going to use that again on the new fuel rail, but we'll cover that when we get to it. All right, so this particular set of throttle bodies has a idle control motor. It operates this little cam here, which just bumps the throttle a little bit. I'm going to try and reuse that. The ECU that I built has provisions in the software and in the hardware for stepper motor idle control, so we're going to try and configure that. I've messed with it a little bit, and I can get the thing to drive the stepper motor. We'll figure out a little more later what the actual, if I can get the settings right to make it work. If not, we'll just bypass the idle settings altogether, and I'll add a thumb screw in here to make it manually adjustable. So for this particular set of throttle bodies, one of the reasons I picked this one is that it's not a common shaft. So there's not a single throttle blade shaft that goes all the way through to all three of these throttle blades. In this one, there are actually 3 independent throttle bodies that are bolted together here in the middle. So these were just held together by a couple of 5mm bolts top and bottom. And like I said, I already loosened these up. These things were really stubborn to get loose to begin with. So I've already broken them loose and taken these loose. Oops. What we got to do is just pop those off, and then these guys will basically, you just kind of jiggle them and they'll fall apart. and then we got to figure out how to space them appropriately to match what's on the bike. So for these, so just kind of give them a little wiggle, and they pop apart like so. One of the things that I have yet to do on these that I'll show you a little more close up later is extend the balance blades. So just like any multi-carb setup, these multiple throttle body setups, you can individually tune how far open each throttle blade is with these screws in respect to the center one on this case. But when I move these need to be moved 6 millimeters farther apart from each other. So when I space them out, you'll see that these throttle blade extensions here, these idle extensions here, they don't, or rather these balance extensions, they don't quite reach to the screw, so I have to weld on some extensions. I haven't done that yet, partially because I wanted to show you guys how this process goes. This joint right here has this extra piece in it that adds a little bit of complexity to the overall setup, so I'll show you how I dealt with that as well, if I can get these things apart. My gosh. Okay, so there's the first one off, and this one's a little stubborn today. My goodness, what have I done? Ah, just kidding, I forgot a screw. That explains that, you dummy. It's funny, I even mentioned to you guys about this extra point in the middle there that I had to deal with, and I totally forgot to take the screw out. Now it's going to fight with me. And I don't think I have a 7mm wrench here, so I'm going to have to use pliers on that. Don't judge me. So if it just so randomly happens any of you out there who are watching this are familiar with these Triumph throttle bodies and recognize that my throttle position sensor connector is not the correct one for a Triumph Daytona, that is because I've already swapped it out for a Deutsch connector that I'm going to use for my ECU wiring, because the one that was on there was kind of a proprietary 3-pin connector that was not as easy to find. And I already had a whole kit of these Deutsch connectors, so I just pulled a 3. Alright. Hey, look at that. When you take all the screws out, it comes apart a lot easier. Okay. So now we've got all 3 of these throttle bodies. And for the most part, they're almost identical. This one is capped on the end of its throttle blade shaft. And I've got these all screwed up backwards here. This one has the throttle position sensor on it. And then this is the center one that has the throttle cable connections. All right, so the cables will come in here, and it's a dual cable, so it's a push-pull. And you know, I have my manual idle adjustment there if I need it. And these are the 2 tabs I was talking about that I need to extend. So I've got some 2mm steel. I'll just cut a little 6mm long extension, and that will slip in between this spring and that screw so that we can adjust the balance between these when we actually get on the bike. Alright, so how did I space these out? Well, I got some aluminum bar stock, and I made 4 of these guys. Okay, so they have a little bit of a recess that sits over that shoulder, and then there's a little bit of a protrusion that sits inside there. And I made 4 of those. So that bolts, 2 of those will bolt these 2 together with some slightly longer 5mm bolts that I bought. I went with socket heads on these instead of the hex head that were on the factory ones, just because I prefer to use socket head fasteners whenever possible. Can't necessarily tell you why, I just do. There's my 4mm Allen wrench, we'll run those together. So once we get all these assembled and you're like, okay, cool, I've got a set of throttle bodies that now match the cylinder spacing. You already said that the diameter was different. Well, I'll show you in just a minute how I dealt with that. I did it differently on this bike, and that's something that if you choose to do this on your own, you're going to have to figure out a way that works for your particular bike setup. My XJ750 had bolt-on rubber boots or intake manifold, if you will, that connected the yep, I can't words now. Anyways, I had a bolt-on set of manifold boots that connected the carburetors to the engine, whereas this one, there's like tubes that are cast into the cylinder head that provided the mounting surface. So it was just a tube that was clamped on both ends to the carburetor, and one to the carburetor and one to the engine. So there was nothing that I could make. I couldn't make a bolt-on adapter. So did a little something different on those, and we'll take the camera over to the bike here in just a second. So I did that, and I left out the idle piece on this for now, just to kind of show you guys, just for spacing purposes, how this worked out. So there's all 4 of those put together. And then I know I mentioned to you guys before about fuel injectors. So I went on the interwebs, specifically to eBay this time, and I picked out some injectors that were close to what I thought I needed flow rate wise for the amount of power I'm looking to make with the turbo on this bike. And these are some 450cc injectors from AUS Injection Inc. I picked these because they were relatively fair price, they had good reviews, and they came with data sheets. So if you plan on doing any custom tuning at all, you need to make sure that your injectors come with some sort of a data sheet. So this one gives you, this one has them specifically by serial number, what the flow rate was. These were all pretty closely matched. You see I got one a little heavy here. That's the one I'm not going to use. They come in a set of 4. I bought 4. I'm only going to use 3. So I left this one out, as that one had a little bit different flow rate across the board. So down here gives you the offset chart, so I can change the timing offsets in the ECU to compensate for any voltage deflections in my electrical system. But anyways, so what I got here now is I need to mount these injectors. So in order to do that, I needed a fuel rail. This is, or was, a piece of just fuel rail stock. You can buy a just piece of a fuel rail stock extruded aluminum. I think this was like 15-20 bucks maybe on eBay. I don't remember exactly. So what I did is I measured out the spacing of the injectors on the throttle bodies, and then measured out what size hole I needed for these injectors to fit snugly in there. And then I bored out the holes on the CNC so that these fit snugly in there. I welded a cap into one end because this is a returnless, or the return for this fuel system is in the tank with the pump. And the other end I've got a threaded boss. I need to clean up the weld on that still, but got a threaded boss where I'm going to put a fuel pressure sensor so the ECU can compensate if I have a drop in fuel pressure. But I still wanted to use this fuel inlet because it was a convenient way to get fuel in. I already had it, and it works out really well with the quick connect. So machined a hole that was just like the one on the existing fuel rail for this guy, and then this is going to bolt on like this. So then we're going to put the injectors in here with the connectors facing that direction. Okay. Just like so. I think I may have put those in the wrong direction, but that's all right. And then when I got these up here and I started trying to figure out how I was going to mount everything, it was pretty obvious to me pretty quickly that this was going to be a tricky setup to try and find some sort of way to clamp this fuel rail down to the throttle bodies. And my good friend Matt made a really good suggestion. He's like, man, it'd be great if you had some bolts that were threaded on opposite, or some studs that were threaded oppositely on different direction on each end. And I found these. These particular ones came from Lunsford Racing. And these are turnbuckle screws. So one end is a left-hand thread and the other is a right-hand thread. These are 5mm. These just happen to be titanium because this is what they had. So these holes were already right-hand thread, so I wasn't going to try and change those. So I got a left-hand tap and I drilled and tapped corresponding holes that were left-hand thread. So now all I got to do is thread these in here before I mount the fuel rail. So I just go ahead and fully bottom these out to start off with. And then, oops, I'm gonna throw it on the floor first. So we thread those in, they're kind of reverse threaded. And then we'll drop the injectors back into their little spots, like so. If I can just quit throwing things around, would be great. I put that on backwards, didn't I? I did. There we go, that's better. Okay, and then I've got somewhere I have a wrench that fits these just perfectly. So we back this out just a little bit. So now until they all make contact, get about the same turns on either side. Then we can, once everything is lined up nicely, the injectors all in their little pockets, we can start threading these into the throttle body, and each turn actually pulls it twice as far as it would normally, because it's just like a turnbuckle, right? You're turning the threads into the throttle bodies one turn while you're turning them into the fuel rail at the same rate. So we twist those down and that would mount the throttle body. Worked out really well. I went ahead and pressure tested this. I pressure tested up to about 60 psi. I only ever planned to run about 45 psi. Anyway, so that worked out really well. The only things I really have left to do to make this work out is I'm going to pull these vacuum ports. I'm going to heat the throttle bodies up, pull these vacuum ports out, and weld in some plugs to cover these, because I have ports already on the engine to give you my vacuum reference for the ECU and also for the things like the blow-off valve and the wastegate. So I already have a reference source there, so I don't need one off of these throttle bodies. So that's how I dealt with the throttle bodies for this particular instance. Like I said, it was different on the last bike, but that's how it worked out here. So let's head over to the bike real quick. So I mentioned before, these are tightened down already, but there are extrusions cast directly into the cylinder head here that stuck out for each of the 3 carburetors, and there was a rubber boot that went over with a hose clamp. So what I've done here is I've machined a boss in either side of these pieces of aluminum, and there's an O-ring on the back side of this one as well, and there's an O-ring on this face that seals, for the one inside seals against the engine, and this one will seal against the throttle bodies. And then I put set screws that went into the grooves that the rubber boots used to sit into, so that when you tighten these set screws, it pulls this into the head just a little bit to compress that O-ring. And then it'll do the same thing here on the throttle bodies. So they go into the aluminum pieces there. You can kind of see that. And then when we tighten down those set screws, it actually it catches. You can see where I've tightened them up before. There's some little dimples there. It actually catches on that lip a little bit and pulls the throttle bodies further in and compresses that O-ring to seal everything up really well. So that's how we handle the throttle body side of things. Now, the other things you need to drive a fuel injection system on an engine that was previously carbureted, the ECU needs to know where the engine is in its rotation. So on this one, for the crank trigger, oh, I dumbly covered it. Okay, so for this one, what I've decided to do is use an optical sensor. So I originally hadn't thought of using an optical sensor because I didn't realize they could actually reach these kind of speeds. But I was working on my boss's truck recently, and I saw that his Pathfinder actually had an optical sensor inside the distributor for engine inputs, and kind of triggered me to pursue this. So right down here is a small photo. It's an optical sensor with a photo LED, so it shines light through one of those little black things, and you can't really tell from this angle, but on the back side of that trigger wheel, there's a receiver diode. And so in here there's only 3 pins. I have to put 5 volts ground, and then one of them is the trigger that feeds out to the ECU. And this wheel I machined has 1/16 slots. You can see there's a missing one right there. So this is a 36-1 effectively toothed trigger wheel. So a lot of people use these with variable reluctance sensors or Hall effect sensors, and that's what I did on my last bike. Was I built a wheel with magnets and used a Hall effect sensor. The problem I found is that neodymium magnets don't maintain their magnetivity. They stop being magnets above about 200 degrees, and with the engine heating up, that heat was transferred through the aluminum and ended up causing the magnets to lose their magnetivity and basically killed the engine. And eventually I ended up switching over to I forget the type of magnet, but it's a higher temperature stable magnet. Anyways, so I haven't actually run this engine yet, so I don't know if this is going to work. I tested this trigger wheel with this sensor, and I've spun it. I spun this up to about 10,000 RPM. Don't ask how with the router. Anyways, and it worked really well, and I was able to still get a good signal off of this sensor. I don't know how well this sensor is going to hold up to heat. That's the only big concern at this point. I don't know how susceptible these things are going to be to heat. So there's that. So that's how I got the crank position. Now for cam position, on the last bike, I actually just drilled a small hole right on one of the flat spots on the cam where there's normally a wrench flat, and I put a magnet and used a Hall effect sensor. For this one, since there was a mechanical tachometer drive right here off the top of the cylinder head, I machined this piece. This gear piece was from an original tachometer cable, and then the gear ratio between the camshaft and this output of this cam thing of the tach drive was 2-to-1, and the software for the ECU I'm using only allows either 4 or single tooth cam output. So I figured, well, I can go single tooth if I just double this. So I put 2 magnets. You can see these little neodymium magnets there. I put 2 of them on there. Figured it would, if it was catching every other revolution, it would look like the same speed as the camshaft rotation. So that fits in there, and then I've got a Hall effect sensor mounted in a ring that will get retained by this bolt right here, I believe. Yeah. So I just made this little aluminum piece here, and then I've epoxied in a Hall effect sensor in there, and that will just get thrown around and bolt on right over the tap of that sensor, and that lines up with the magnet, and that'll be the camshaft input. So the only things really left as far as inputs for the ECU will be temperature sensor, and since this is an air-cooled bike, I decided to go with oil temperature. So I'm going to do the same thing I did on the previous bike. I haven't actually done it yet, but basically I'm going to take off the what used to be a canister-style oil filter. So this big, huge, clunky thing here, I'm going to ditch this altogether, and then I'm going to machine a aluminum piece that bolts down there where the oil filter used to go, and it'll use a standard, motorcycle-style spin-on oil filter. That'll also allow me to have provisions for some oil lines to run up here and mount an oil cooler. Since we're running a turbo and the turbo's going to use oil, I figured it'd be nice to actually keep the oil cool since we're going to be pushing this engine a little harder than it was ever intended to be. So we'll have an oil cooler, and that'll give me also I can connect a temperature sensor to that in the output from the engine, so I'll know what engine temperature is based on oil temp. And then we'll need an oxygen sensor. So if you know much about oxygen sensors, you have 2 major choices, either a wideband or a narrowband. My ECU allows for the use of a wideband. It doesn't actually have the wideband controller built into it, so I'm probably going to use like the Lambda Spartan or one of the relatively inexpensive, no frills wideband sensor and driver, because I don't need a gauge independent, because if I need that, I can always see it through my ECU. So I'm going to install the wideband oxygen sensor, just a single one. It's one of the reasons, that and the turbo, the main reasons I went to a 3-into-1. Not a big fan of front-mounted turbos on bikes. I know it would be beneficial for cooling and whatnot, but the way I looked at it is if I mount a turbo here, I've already got the tires pretty close. I could trim these pipes back, put the turbo here, but then I got to run intake piping all the way around back. So I decided that I'm going to do a rear mount turbo on this. So you can see right now, this header I got brings the exhaust back here. I've got some reducers and some pipe. So we're going to plumb that such that the turbo sits like this. Basically right at the back of the engine, just above the swing arm. So that'll allow me to bring the exhaust up there. And then we're going to cut that bulge off the end of the compressor housing and put a 90 on it. And so then all I need is just to build a simple manifold to dump from the turbo directly into the throttle bodies. I wanted to run an intercooler, but I just don't think there's really room here. But back to what I was originally talking about, the output from the turbo will then now allow me to just run straight back and up, and then I can run an undertail exhaust out here, and then we can put the oxygen sensor just past the turbo. The point to all that is if you're installing an oxygen sensor in a turbocharged system, you always want to put the oxygen sensor downstream of the turbo, so after the turbine housing. So the main reason for that is the turbine housing puts some significant amount of restriction on your exhaust, and that extra pressure can throw off your O2 sensor reading. So you always want to put it downstream of the turbo, but as close as possible. So I'm basically going to mount the oxygen sensor kind of, in the pipe, basically just right after this exhaust flange coming out of the back of the turbo there. And then you have a lot of options for coils when you're running a system like this. So the last bike I ran, just some Excel super coils that were made for motorcycles. This time I decided to go with AEM smart coils, just because it's one less thing I have to do as far as electronics, because these are capable to be triggered directly from the ECU. They don't require any sort of separate igniter box. You may find it odd, there are 5 wires there. Well, if you look at the pinouts on these, there are 3 separate grounds. There's an ECU ground, a trigger ground, and a battery ground, the logic ground, and then the center pin actually goes directly. They want you to ground it directly to the cylinder head that the spark plug is firing into. But anyway, so I got 3 of these guys, so we'll be triggering these directly from the ECU, so I can control timing per cylinder if I choose to. And then we already talked about the injectors. Those will be also directly controlled from the ECU. And I keep saying we're going to be doing all these things from an ECU. Well, that gets back to the main heart of what makes fuel injecting these bikes so possible. And in my application, that is SpeedDuino. So there are lots and lots of options for ECUs. This Mega Squirt is pretty simple, pretty popular. I've chosen to go with SpeedDuino because I like the open source nature. I'm relatively cheap, but I'm also really handy with electronics. So I've built several of these ECUs now. I did one for my buddy's truck that we turbocharged, and then I also did the one for my last bike, and I've used a lot of different connectors on them. I've used some DB37 connectors. If you go online, you can buy a pre-made SpeedDuino circuit board, and it looks, I believe this is the official one. Yeah, it looks just like this. And they give you a 40-pin output connector. Wait, is this the right one? Yeah, this is the official SpeedDuino board. So we bought some of these. Then I liked some other options, because this, you stack an Arduino Mega on the bottom of it, and then you have some components stick out the top. The whole thing ends up being, a couple inches thick when it's all said and done. So I've made some various other attempts at it over the years. This is the board version that's running on my current bike. I screwed up on this one, and I chose the wrong transistor footprint. So you can see on this one here, they're just the standard TO220 footprint MOSFETs, and I picked I forget what these are called, but I picked the wrong footprint for these transistors, and so I wasted a lot of board space. You can see there's a lot of just wasted space on this board. I was trying to make this board smaller and more efficient. I didn't really actually save myself a lot of space. As you can see here, compared to the new board, it's really not any smaller, but some major improvements I made was switching to this connector. This is a TE, Tyco Electronics connectivity. I forget the actual part number. But yeah, these are relatively inexpensive. They're about $16 for the board side, and I think it's like $12 or $15 for the cable side. But they're waterproof, and they're relatively robust. They latch relatively well. So yeah, I switched over to using these connectors now on the new ones. And I actually have some new boards coming from China right now that are all... I've converted all of the individual discrete components with the exception of these 4 big resistors. I've converted everything to surface mount, and I've had them all populated for me. So all I'll have to do when I get these new boards in, I'll have to add the 1 chip socket for the SP721. I couldn't find that in the surface mount through the vendor. So that's it's a protection circuit. And then I'll have to add those 4 resistors, and then just the pin headers for the Arduino. I switched out, I got rid of the voltage regulation system that they had built in. I wasn't a big fan of it, and I feel like this is it's $1.50 for like a handful of these adjustable voltage regulator modules. They're clean, they're robust, and you just put pin sockets on, and if you break one, if you do something to damage your voltage regulator board, you literally just unsocket this, pop it out, and pop in a new one. It costs you a couple bucks in a few minutes. Easy to do. The other major difference I did was switching to this Arduino 2560 Mega Pro Mini, I think they're called. They're about $7 to $10 a piece. They're cheap. They're easy to find. They have a much tighter footprint, so they have all the exact same components as a Arduino Mega. It's just in a footprint that's less than half the size. So I switched over to that, and the great news is that by stacking it on top, it still allows me to populate the underside, with all these capacitors and resistors, so I'm not losing any footprint space. I also added a Bluetooth board to this one. There's only one major downside I'm having with having the Bluetooth on there, is that it shares the same serial port as the USB connector. So if you have the Bluetooth board connected and powered up, you can't read or write from the board via USB. So you can read and write via Bluetooth, which is fine, but you can't use USB. So that's something I had to work around. On the newer boards, I'm thinking about including I didn't on the last one, but on my next version of boards, I'm thinking about including a switch on the power line for the Bluetooth. So you just have a little tiny panel-mounted toggle switch there that you could turn off power to the Bluetooth, so you could operate externally. Also, this one includes this pressure sensor. It's a MPX 4250. I believe that's a 3-bar map sensor. You can use it for map sensor or an atmosphere sensor. But you can't use this. The way this board is configured, you can't use this sensor and an external map sensor at the same time because they share the same input pin to the CPU. You can add a separate sensor via one of your prototyping ports. I cut down the number of prototyping pins on these. This is the prototype area on the last version of board I made, and I used one of these once, so I finally realized I don't need a whole lot of those. So on the later model of boards, I broke out 5 analog pins, 5 digital pins, 5 5-volt pins, 5 grounds, and 5 12-volt pins. So I feel like that's enough to do just about anything you want to do that's not already included here. So anyways, I haven't actually put up my Eagle files and stuff for these boards, but if anybody wants them, please reach out, let me know. I'll be glad to share. It's clearly the whole SpeedDuino stuff the whole SpeedDuino project is open source. So I made these boards based on the diagrams that are freely published. So there's nothing proprietary here. I changed the layout a little bit, but I'm not afraid to share that. So if anybody wants to use my designs, please ask. I'll send you the files. Also, I'm going to have about 4 extra fully built surface mount ECUs. I removed a few components. I'm not going to go into that now, but if anybody's interested, I will be selling those here shortly once they come in from China and I verify that they actually work. So if you're interested, drop me a line and I'll see what we can work out. So this is the cable end of the connector I was trying to find earlier. It was buried. So this will plug into this ECU. It's a little bit fat, especially for motorcycle use, but I prefer it greatly to these DB37 plugs. You can make your own cables for these, but it gets really cumbersome because these pins are so close to each other. And if you buy a cable and cut the end off, which is what I did in the last one, you find you're working with like 26, 28 gauge wire inside of there. It still seems to work. I've been driving my, I've got a couple hundred miles on my bike now, and probably 100 plus more on the tune, on the dyno, and no failures in the wiring. So it seems to be holding up, but I really didn't like the way it was to wire. It was just kind of cumbersome with those really tiny wires. So these plugs will accept, I believe, a 18 to 22 gauge wire. So I plan on running most everything. Maybe the battery input wire may be a little bit heavier, but everything else I'm going to run 20 gauge wire on this, just to give it a little bit, better chance of long-term survivability. So anyways, that's how I convert these vintage bikes to fuel injection in a nutshell. If you have any questions, please drop them in the comments. I'll try to respond as much as I can. And if you like what I'm doing here, like, subscribe, all that fun stuff. Thanks, and have a wonderful day.